Hi everybody. Today we'll take a look at lesson 2 about moles, and it's going to be all about the mole concept. And our objective will be, at the end of today, we'll be able to convert the number of moles to the number of particles in a sample, or the number of particles to the number of moles in a sample. If you need more help on this, please feel free to see me, ask your friends, read chapter 3 section 3, and find this PowerPoint in the pickup folder. Alright, here's the big idea. We could count atoms or molecules or ions or formula units, types of particles. We could count them by the dozens, hundreds or millions, but quadrillions of them fit on the end of a pin. They're so tiny. We need a number that's bigger than that. Well, confectioners use a baker's dozen. That's 13. Retailers buy things by the gross. That's a dozen, or 144. But chemists use a huge quantity called Avogadro's number. And the number is 6.02 times 10 to the 23rd. It's a mole of particles. There's Amedeo Avogadro right there. And this number is named for him, although it was his students who actually came up with the exact number. So a mole is like a counting unit, like a dozen except for bigger. So we could say, oh, 1 mole of H2O molecules is 6.02 times 10 to the 23rd water molecules. We could say 2 moles of chloride ions is 12 times 10 to the 23rd ions. Or we could sort of work this backwards, and we'll be doing some problems like this. We could say, what if we have 3.01 times 10 to the 23rd atoms? How many moles is this? Well, 3.01 times 10 to the 23rd, let's compare that to 6.02 times 10 to the 23rd. Oh, 3 is half of 6. So this is half as much as a mole. So the answer to this is 0.5 moles of copper atoms. And you could use this for anything you want, such as elephants. How many elephants are there if you have 3 moles of elephants? Well, it's 3 times this number. Let's just estimate this, shall we? 3 times 6 is 18, so the answer is 18, a little bit more, 18.06 I guess, times 10 to the 23rd, which your calculator will show as, instead of 18.06 times 10 to the 23rd, your calculator will say 1.806 times 10 to the 24th. But that's the same number and as this. And so we'll work with these a little while until you really get the hang of it. Alright, well, here's the concept. If you can understand this concept, you'll be fine with moles. A dozen of anything is the same as 12. So we could go from number of eggs to dozen, or we could go from dozens to eggs. We could say, I've got 36 eggs. How many dozen is that? Well, we could do some math here. We could say, well, I want to get rid of eggs as a unit, E, G, G, S. So eggs is on the top. I'll cancel that with eggs here. And I want to get dozen. And we put an equality in here. We could say 1 dozen is equal to 12 eggs. And the math is 36 times 1. Which is 36, divided by 12, which is 3. 3 dozen. We could run this problem backward. Let's say you had 5 dozen eggs. 5 dozen eggs. All right. Oops, not working. Okay. 5 dozen eggs. 5 dozen. 5 dozen. How many eggs is that? Well, we set up what's called a conversion factor, and we want to get rid of the units, which are called dozen. And we want to get eggs. Let's see, 1 dozen is still 12 eggs, is it not? Dozen is on the top, dozen is on the bottom here. When you multiply them, they cancel. And the math is 5 times 12, which is 60. 60 divided by 1, which is still 60 eggs. If you can do that, you can do the mole thing. The only difference is that 1 mole is not equal to 12. It's equal to 6.02 times 10 to the 23rd. This is a big number. It's 6.02, and then move the decimal 23 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 19, 20, 21, 22, 23. Whoa, that's a big number. We did a lab the other day in which we calculated how many molecules of methanol there are in a drop, and we came out to a number which was equivalent to counting that, if you're going to count them, it would have taken you approximately 4 billion lifetimes to count the number of molecules in 1 drop of this stuff. So this number, it's a big number. How do you plug this into your calculator? Well, different calculators do things different ways, but most of them, calculators, work like this. You'd say 6.02 times 10 to the 23rd. 6.02, find the EE button, hit it once, and then click in 23. That's how you plug this in. Let's do our practice problems, shall we? All right, first we're going to go and convert from number of moles to number of particles. So particles over here, you'll see things like atoms or molecules or ions or formula units. The second way, we'll just work this problem backwards, and we'll start off with number of particles, and we'll calculate how many moles this is, just like with the dozen of eggs, problems that we did. All right, so how do you do this? Let's do the second problem, shall we? I should have gotten rid of this first one. That's too easy. What if you had 3 moles of water? How many molecules is it? Well, we want to get rid of moles, so you write down moles here. So moles is on the top in the numerator, right here, and you multiply it by moles in the denominator, and your math teacher would tell you that, oh, on the top and the bottom, they cancel one another. And we want to get molecules, so we'll write M-O-L-E-C, which stands for molecules, on the top. Inside of this conversion factor, the set of brackets, all right, we want to put an equality. What's the equality? How many molecules are there in a mole? Well, 1 mole is 6.02 times 10 to the 23rd. So 1 goes with moles, and 6.02 times 10 to the 23rd goes with molecules. Moles will cancel with moles. Let's do the math. Take your calculator and plug in 3.03 times this number on top, 6.02 EE 23, hit enter, divide by what's on the bottom, in this case it's 1, divide by 1, hit enter, and you have 1.8 times 10 to the 24th. You have to get all that information, 1.8 times 10 to the 24th molecules of water. Let's try another one. Well, let's go right down, you could use this with chickens too. Let's say you had 0.14 moles of chickens. Would you have a lot of chickens? Let's find out. Well, we want to get chickens here. All right, we want to get rid of moles as a unit. M-O-L goes down here then. Moles on the top, moles on the bottom, cancel. We want to get chickens here. How many chickens are there in a mole? Well, just like there's always 12 in a dozen. In this case, there's always 6.02 times 10 to the 23rd in a mole. So you write in 6.02 times 10 to the 23rd. Chickens is 1 mole. Moles cancel with moles. All right, so you plug in 0.14 times 6.02 EE 23, and your answer is 8.4 times 10 to the 22nd. 8.4 times 10 to the 22nd chickens. A lot of chickens. Fill up half of the solar system with chickens, something like that. Here you have moles, and you want to go to number of ions. So you get rid of moles. Moles on the top, moles on the bottom, and you write down ions here. How many ions are there in a mole? Well, there's always 6.02 times 10 to the 23rd of anything in one mole. Take this number, 1.2 EE 12, times this top number, 6.02 times 10 to the 23rd, 6.02 EE 23, hit enter, divide by the bottom number, hit enter, and you'll have your answer. Well, we just spent some time converting from moles to number of particles. Now let's go from number of particles to moles. So let's say you had 6.7 times 10 to the 25th, 6.7 times 10 to the 25th atoms of gold. We want to figure out how many moles that is. Well, let's get rid of atoms by putting atoms down here. So atoms is on the top here, it's in the numerator. Atoms is on the bottom here, it's in the denominator. And we want to get moles, M-O-L. Well, how many atoms are there in a mole? 6.02 times 10 to the 23rd of them. Make sure you write it down here. 6.02 times 10 to the 23rd atoms in 1 mole. So 6.02 times 10 to the 23rd always goes with the number of particles, be they ions or be they molecules or formula units. So your math is 6.7 EE25 times the top, hit enter, divide by the bottom, hit enter, and you've got your answer. And the answer should be something like, this is to the 25th, this is to the 23rd, so this is 2 bigger, it's in the neighborhood of 100. Your answer should be fairly close to 100. Let's try it. Clear? 6.7 EE25 times 1, hit enter, divide by 6.02 EE23, there you go, it's 111, which is what we predicted, about 111 moles. Here's another problem. It says a sample of water has this many molecules, that many particles. How many moles is this? So you write down 2.5 times 10 to the 29th molecules, M-O-L-E-C, molex. Save some space, equal sign. We want to, how many moles? All right, we want to get moles. We need a conversion factor right there. And we want to get rid of molecules, M-O-L-E-C, and we want to get moles, M-O-L. 1 mole is equal to 6.02 times 10 to the 23rd. And your answer should be something like it's in the million, a little bit less than a million. 2.5 EE29 times 1 equals, divide by 6.02 EE23, and it's, oh boy, 415,000. 415,000 moles, that's a lot of moles. Okay, so that's it for this lesson. We've been working on converting number of particles to moles. How did we get here? We got here like this. We said that Avogadro's number is a big number. It's bigger than 12, it's bigger than a gross, it's bigger than, it's 6.02 times 10 to the 23rd. We said that if you understand the concept of 1 dozen equaling 12 eggs, you'll understand moles. Except for the number is 6.02 times 10 to the 23rd. And the next slide has all of our sample problems in which we were given a certain number of particles and we were asked to convert to number of moles. Or we were given number of moles and we converted to number of particles. And there's our work that we did. So thank you, and if you have any questions, please feel free to stop in anytime after school, before school. Send me an email and we'll figure this out.